Hey everyone, this second video is going to build on the ideas we talked about in video 1 with S, P, D, and F sublevels and start applying it to the shape of the periodic table. So as we learned before, our S sublevel holds a maximum of 2 electrons, P 6, D 10, and F 14. And if you'll notice, on our periodic table, if you ever took a look at this without understanding Schrodinger, it seems like the shape of the periodic table is pretty random. Kind of looks like some weird building or castle or something with like little turrets and big globs and sections. But we're going to start breaking it down to try and figure out why it looks the way it does. So let's start over here on the left, where I see kind of this smokestack-like column that's for the most part 2 elements wide. Now, yes, there is this little space right here that doesn't seem to be filled, but what I'm going to do is grab this block from over here. On your periodic tables, right, it's helium. We're going to bring it on over and pretend like it kind of lives on this side of the periodic table for our intents and purposes now. The reason it got plopped over here is something that we'll discuss when we really go into depth into trends of the periodic table. So right now what I see is this kind of column 2 blocks wide. That leaves over on the right-hand side of the periodic table kind of a squarish-like chunk that, if I count, is 1, 2, 3, 4, 5, 6 elements wide. And that seems to extend all the way down to the bottom of the table. And that makes readily apparent this section in the middle of the table that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements wide. So I'm going to kind of highlight that to show that it's starting to stand out to me. And of course, kind of down here on its lonesome, on the bottom of the table, is this block of elements that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 elements wide. If those numbers sound familiar, then you've been paying attention, right? Those 2, 6, 10, and 14 correspond exactly to the number of electrons that can fit into each sublevel. And we're going to use that to our advantage when we're starting to figure out why the periodic table looks the way it does and where electrons go in each element in a more specific fashion. So what we're going to find is this column over here that's 2 elements wide, we're going to refer to as our S block, because we know that number 2 is coming from our S sublevel. 2 electrons can fit into our S sublevel, so these elements over here must have something to do with filling up our S sublevel. As you can imagine, the section of the periodic table that's 6 elements wide must have something to do with filling up our P sublevel. So we're going to call this section over here the P block. And in the middle, the 10 element wide section, we'll call that our D block, because it must have something to do with putting electrons into the D orbitals in the D sublevel. And again, at the bottom, we've now got space to fill orbitals in our F sublevel. If we start putting numbers on this, I'm going to refer back up to the diagram we did in video 1. The S sublevel is present in every single energy level we've got, right? Starting with energy level 1 and going all the way up to the maximum number of energy levels that we've observed in an element to date, 7. If I look at my P sublevel, in my diagram, P started appearing in my second energy level. So on my periodic table, I know we start dealing with filling up P sublevel orbitals on our second energy level. And that will continue on all the way down through our 7th. This is where the table starts getting a little weird. Don't let it stress you out too much. Up top, we see that the D sublevel appears in our 3rd energy level. So we know we must start putting electrons into orbitals in sublevel D in our 3rd energy level. Note that doesn't exactly match what we have over here in S. Don't worry about it. It's a little quirk of the periodic table, but it will be useful when we start writing more precise electron configurations. So you'll see if I fill that out on the periodic table, I only get down to 6. Again, this just has to do with the limited number of elements that we currently know of. Same deal goes for our F stuff, right? Our F sublevel started appearing in energy level 4. So that means we must start filling up orbitals in our F sublevel on energy level 4. And that leaves those 2 rows to be labeled as 4 and 5. What we're going to do with this is start changing the way we approach writing electron configurations. We're going to move away from Bohr's just total number of electrons in an energy level, right? 2, 8, 8, 2, and starting to think more specifically about exactly where those electrons go. Are they filling orbitals in the S sublevel, or are they going to the P sublevel, or are they filling S's, P's, and D's? And that's going to give us a more deeper, more meaningful insight about not only where electrons are, but how they're going to be able to behave. So this will pay off in the long run, and it'll give us a more precise address for each of our electrons. So again, that difference is that Bohr is just going to tell us total number of electrons in an energy level. Schrödinger is going to tell us exactly where those electrons are within an energy level, whether they're in S, P's, or D's sublevels. We're really not going to deal with F sublevel stuff at all. Those numbers are just too big and too hectic. So for now, again, go back, rewind, revisit parts of the video, make sure you're clear on how we're using the periodic table to start breaking it down into whether we're filling electrons in an S sublevel, a P sublevel, a D sublevel, or an F sublevel. Make sure things are filled out on your mini lesson, and when you're ready to move on to video 3, that's when we'll start getting cracking with writing those electron configurations in a new way.